The next function we have is what we call the absolute value function. Now, as far as this one goes, it has a similar look initially to our quadratic function, in that it has 1, 1, and negative 1, 1 as points on it. But we see that it changes beyond those 2 points. So our equation for the parent graph is just y equals the absolute value of x. We have to find some domain and range, x-intercepts, y-intercepts, all that kind of good stuff. So our domain, hopefully you notice that you can use any input for the absolute value function, which means there's no values we can't have in the domain. So our domain is from -0 or negative infinity to positive infinity. But our range, notice that our graph never falls into the negative y values. So that means that our range has to remain positive. So our range is going to have values from 0 to positive infinity. It's only values that are greater than 0. X-intercepts and y-intercepts, those end up being the same point again at 0, 0, which, interestingly enough, is also our locator point, or vertex if you want to call it that, depending on the graph, and that would be our HK. Other than that, it has similar characteristics to the quadratic function, but we notice that, on the quadratic function where you would have 2, 4, we actually have 2, 2. On the quadratic function, we would have the point 3, 9, and we have the point 3, 3. So it's more of a linear function. So when you draw this one, it is appropriate to have it come together in a V shape, whereas the quadratic, we want to have it in a curve at the vertex.